Hi guys, welcome back. So just as in case of PCA, I have selected a data set which was relevant in terms of PCA analysis or rather PC analysis. For clustering also I'm going to use something which is going to make sense in terms of clustering. If I use a smaller data set which I will use for the project so that you guys doesn't have many issues while working on it, but as far as this tutorial is concerned, it is very important to use dataset providing us relevant information pertaining to the model in question. So right now we are going to look at clustering. So this is something where we need a data set which is kind of relevant for clustering. And when I say relevant, clustering is usually used in marketing, segmentation, things like that, surveys, basically where you need to create segments. Though it is useful in data reduction, but in terms of business practices, industry application. Now, of course, clustering is used for data reduction. In fact, when you create segments out of a bigger population, you end up reducing data. But the primary reason why clustering or k-means is so popular because it provides opportunity to businesses to look deep inside their data. A lot of time it is not easy to find out the patterns even with domain expertise. But k-means can do that with fair ease. Of course, it will need help from domain experts in terms of providing the number of Ks, but overall it does fairly good job when it comes to creating these segments. So now coming to the data set we are going to use. So you can download this data set from this URL. Please go through this names file. This is a water treatment data. So you will find good information about all these variables here. Please note that just as with PCAs, for clustering also you need to use numerical data. So whenever you are working with the data where we have characters, factors, we will need to drop them or use encoding to label them numerically. So this is our data set which we are going to use. So let's jump into our studio. So first, like always, run this command and load the data set. Let's look into this. We have these question marks indicating missing value. We have roughly 39 columns, which is again a good thing. Observations are 527. So in terms of numbers of observation, they are limited. If you go back to this names file, you see these variables: input flow to plant, input zinc to plant, input pH to plant. Now, all these are so similar that if we were to create categories based on these, we won't know where to start. I mean, if we pick one, we may end up losing something else. So everything is so closely related to what they do. Now, of course, in other domain, other industries, we will have different kind of columns, but again, they will have similar challenge that variables might be closely related to each other to the naked eyes. But if we run our algorithm, it will be able to extract better information and it will know in reality where they are related to each other and where they are not. So instead of us making judgment calls, our model will make better decisions based on data. Let's name these columns. There are 39 columns. So I have created these labels here. I have got these names from the name file. So let's run them. And now we can print the number of NAs. Okay, I haven't ran this command, so it's not able to find any NAs here. And this is another lesson which you can learn, that if we don't add NAs into our file, it will become very hard for us to find out missing values or values which are not in the correct format. Like for example, question mark. This is something which is essentially a missing value, but this is not in the correct format. So I need to run this command, again run this one. And now if I run this, I will find the numbers. So we have 591 values, which is sizable. I mean, really good amount of data. All these columns, we have total 39 columns, and I think it's a lot of maximum columns have missing values. Let's run str function to see the properties of the data. First column is a factor and everything else is integers, numbers, which is a good thing. That's going to help us. Let's load Amelia library and use missmap function to explore this missing data. So you can see that overall 3% data is missing, and there are multiple columns with missing data. So we need to do something about it. Now, of course, when you are working on clustering, there's a concept of scaling the data, which essentially means that let's say we have two columns. In one column, you have age. Now, usually when we are talking about age, we will have values from 0 to 100. Okay. Let's say we are dealing with an e-commerce website. There are two columns, age and prices. Age will have values ranging from 0 to 100, but price column will have a huge variation. When it comes to value, it could be 10 or it could be 10,000 or maybe let's say a million. So both of these columns are at a very different scale. So if we were to run a clustering on it, keeping everything else constant, our model will create clusters with numbers which are close to each other. So it may end up putting age 50 and price 50 in same cluster, which is not going to paint the true picture. Our model will have tough time responding to these differences in the scale. Therefore, it is recommended to use scaling in these scenarios. In fact, lots of machine learning models and not just clustering need scaling for optimum performance if we are dealing with columns where we have this huge variation in terms of scale. So, scaling is very important. You should always review your data while working on a clustering problem. Make sure that if there are any major deviations or variations, we convert all these values to something which is more optimum. And to do that, we can use scale function. This function will automatically scale all the values, which essentially means that putting them in some kind of range. And you will see these things in a bit. Just understand that we need to do scaling if we have multiple columns and the values are in entirely different space, in entirely different scale. In case of our data set, we have lots of values which are missing. So let's go back to these columns and see. So here we have NAs. If you see, these values are 206, 236, 148, 204. Here again we have similar kind of values. Here again we have values which are roughly 150, 200, those kind of values. Here we have values which are 16, 29, 38, these kind of values under 50. Again, column with similar range. Now we have so many columns that we can't even drop them. Now, the right way of handling this situation would be to use something like KNN. In KNN, we can work on individual columns and we can find out correct values for replacing the missing values. In many cases, in fact, if these number of columns were lesser, I would have gone with something like mean or median for replacement. But we have so many columns that if I were to manually target these columns one by one and replace them with mean or median, it will take a lot of time. And our focus right now is clustering, which cannot be performed if we have missing values in our data set. This is point number 2. You cannot perform clustering with factors and those kind of variables, and you cannot perform clustering if you have missing value in your data set. So let's say we replace NAs with 50. So if I run this command, it will replace NAs with 50. And yes, if you think that instead of 50, we can use some other value, you can change it. In fact, I will suggest you to change it and see if there is any impact on the final outcome of our code. So here, these things are in a sync. Maybe in other columns where we had values around 150, 200, we could have used some other value. But for now, let's go ahead with 50. So now we have all the values. So we can create a new object where we use a scale function to scale our data. So now let's run it. Now, as you can see, we have encountered this error. We have encountered this error because the column 1 is a factor, which we have seen here. Now, therefore, scaling is not working on it. So now we are passing this data set without column 1. Now if I run this, it will work. And if we view this scaled water, you will see that all these values here are scaled in a specific range. So if we go to this column, let's say RDDQOS, we have 50, 87. And now if we go to this column, this is our column which is having scaled values instead of original values. Values from minus 2.5 to 0.5, 0.66. An entire data set is having values in same range. Everything is converted into these smaller numbers. Now our model can deliver optimum results. Now it can make sense of it. Because the variance is in a particular range, it has gone down significantly. Now it is ready for implementing k-means clustering. But instead of using 100% arbitration, let me show you a method which is used in industry for finding out an optimum number for k. So as I mentioned, we need to feed or rather manually set the number of k or clusters we want in our model. But instead of 100% based on intuition, we can use this technique. There are 2 to 3 methods which are used. I'm going to show you one which is easy and very efficient. So this will require you to install this package nbclust. And let me tell you, if you haven't seen this method in most tutorial you have seen earlier on k-means, it doesn't mean that they were wrong. It's just that they were not covering the industry angle here. In industries nowadays, instead of just depending upon intuitions, lot of experienced data scientists are using some kind of technical basis for deciding on the number of k, number of clusters they want. And this is one method which is really popular for finding out an optimum number for clusters. So install this package. If you run this command, you will find that this is a really cool function. Let me run this again. Okay, we need to first import the library. Now let's run this to check the help section. You can see that this method is using 30 different indices for finding the optimum number. You can scroll down, you can find that these are the number of methods it is using, and it's really very detailed information here. If you are interested in the maths and under the hood information, you can check out this section. This will really provide useful information. And this method is really cool. This method is really helpful when it comes to at least finding out your starting point. So you can start from here and then iteratively you can try and see what works for you. So we need to use this function nbclust. Again, we will set seed just to make sure there is consistency. I am supplying the name of my data set -1 column, which is the factor in our case. I am mentioning that I need to use Euclidean, and method means that if you see there are other options also. These are the options which you can use in the method, but we are going to use k-means because that's what we are performing here. So now if I run this, and yeah, I'm going to assign this value to this object. And this will produce an output which will help us to get the optimum number for our clusters. And this will take some time to run. In this case, these graphs are not very helpful, but that's not the case always. This is the elbow chart which we have already seen. So as I have mentioned earlier, it's recommended to not go beyond the elbow point. So in somewhere in this range, and these are number of clusters. So for example, this is number 1, number 2, number 3. So if we were to use this chart to select number of clusters we should go for, so we should select somewhere around this, or this maybe maximum, this value. So 1, 2, 3, 4, 5 number of clusters. As per this maximum, it could be 5, because you can see that this region is not very helpful. But we don't need to do all these things because our model, this function, will tell us the optimum number of clusters which should be used. So according to majority rule, the best number of clusters is 3. So for this data set, this method is suggesting us to use 3 clusters. And out of all the indices, this is the voting pattern. So 1 has suggested 2 clusters, 12 has suggested 3 clusters, 4 have suggested 5 clusters. And if you are not sure what we are talking about, these are the indices here. So there are 30 indices here. And it will use them to select how many clusters should be used for the given data set. And as you can see, this is really effective. Instead of depending upon intuition, we can have some kind of guidance here. If you look at the graph, maybe if not 3, we can also try 4 or 5. But point is, when you have a direction like this, when you know that 4 are mentioning to use 5 or 12 or 14, at least we have some kind of basis for our analysis. And then of course, as far as k-means is concerned, we always evolve. Our model always evolve with trial and error. So instead of just throwing some number out there, we can have some kind of basis for that number. So let's plot a table for this. So this table simply means that 12 are saying 3, 4 indices are proposing 5, and so on. So all this voting here is represented in this table. And then let's put same information in a histogram, or rather bar plot. So this is the bar plot. This is again representing the same information. So we have 12 indices here and so on. And now we can run our k-mean model. And to do that, we need to use this function k-means. For x, we need to supply our scaled data set. The center, which is k in k-means, we need to provide 3 based on this output. But we can also provide 4, 5, and there's no harm in trying other numbers here. But for demonstration, let's go with this. N start simply means number of iterations. So our model will try 10 times before stopping. So there will be 10 iteration. Usually you will see that a lot of people use 20 to 25 iteration, but just to reduce the computational time here, I'm using 10. But yeah, usually even I will use 25 or 30 or something like that. So for now, let's run this command. And now we have successfully implemented k-mean algorithm. Let's see what kind of information is there. So this first line is telling us how many clusters are there and how many values are there in individual clusters. So we have 3 clusters. The biggest and the first cluster is having 252 values. Second cluster is having 250 values. And third cluster is having 25 data elements. This is the cluster mean, which is irrelevant in this case because we have used scaled values. So this is based on that scaled data set, which is not the correct. And don't worry, we will go back to our original data set and see how we can use this information there. But this is irrelevant if you are using the scaled data set, which is the right way of doing things. Clustering vector simply indicates the cluster assigned to individual data elements. So as you can see, we have 3 clusters. Row number 1 is assigned to cluster 1. Row number 2 is assigned to cluster 1. Row number 3 is assigned to cluster 2. This row here, maybe 325, is assigned to cluster 3. Row number means serial number. In the spreadsheet, these are organized in rows. So this clustering vector will simply mention all the data elements and the cluster to which they are assigned. This method used here is sum of squares. That information is given here. And then we have attributes from the cluster. So cluster, center. So if we were to run any analysis, we can use $sign and select these individual attributes from here. So in case of PCA, we have used attribute command. Here we are getting this information here as available components. So you can see that this information is really efficient. Now let's perform some more analysis on this. So if you haven't installed FPC package, please go to packages and install FPC. I'm going to install or rather import it, and then we can run this plot cluster and it will display the distribution of the cluster. And you can see that I'm using cluster with $sign, which essentially means that I'm selecting this particular variable from that output. So if I run this, number of clusters chosen by, I think this is 26, but you can ignore that. This part here, the right hand side, is displaying our 3 clusters. So one cluster is here, this is the third one. The first cluster is indicated in black, 1. Then we have the second cluster in red, which is 2. If there were more clusters, this chart will display all the clusters. But right now this information is not very clear. Let's make it better. So let's install and import this cluster package. Let's go through this function here. So you can see that there are a couple of parameters which can be passed into it. So what we are going to do, we are going to use this clustplot function. We are going to first provide the scale dataset. Then we will select the cluster, and this k water is basically the object which we created for k means. So scale dataset, object, and the cluster selected, then color true, shade true, labels 2, lines. If we run this command, you get this one. And this plot here displaying the distribution of all these data elements. And this area here is highly concentrated, so it's not possible to identify individual elements here. But all those 500 plus values, they have been divided into these 3 clusters. You can see that we have 370 here, 319 here, 237 here. We have 396 here. All these clusters have been marked into 1, 2, 3 to make it a bit more easier. So overall, this chart is providing us better information. We can see where these elements are assigned. And if you are still not sure, and now we can go back to our original data set. So I'm using $sign and supplying the name of the column which we want to add here, and then assign the value here. So remember, the only difference with scaled water and water is that values in scaled water are scaled for our analysis. That's it. Rest of the information, everything is same. So when we do this, there's nothing wrong in it. We are just using this data set for adding the column. So now if I run this and view water, you will see that we have a new column, clusters, where we have these values. So it is displaying serial number of cluster to which that particular row is assigned. So this row here is assigned to second cluster. Most of these values are in cluster 1 and 2, and this value here is assigned to third cluster. And this really helps with presentation, especially when you are sharing data with your stakeholders. They may not be very comfortable with it, so you can simply add this column there and share information with them. But again, if they are not comfortable going with 527 rows, we can further streamline this presentation. So now if I run this and this one also, so basically what we are doing here, we are creating a table of these clusters. So you can see that I have created this object here, profile updated. If we view it, you will see that it's a new table where we have information about number of elements assigned to individual clusters, and then the profiling. So earlier when we ran k-means, we got this information here. This was based on scaled data, therefore it wasn't relevant to us. But now this is based on original data. So if we were to share this information with our stakeholder, now it will make sense to them. So this is basically k-means. And what is the significance? As I have mentioned earlier, now we can use this data to perform further analysis, some predictive modeling on this. So here if you see this column here, clusters, 1, 2, 3. Let's say we create a subset with all the values in cluster 1. We can create a column here for cluster 1. We will then train a logistic regression on this subset, and then we can use this model to automatically assign or rather determine if a particular new incoming data element will be assigned to cluster 1 or not. Let's say cluster 1 represent premium customer for your company. Using this model, you can easily identify your incoming premium customers. And there can be many more such use cases where clustering or these segments can be used effectively to increase or generate revenues for your company. That's why clustering is really popular. So that's enough for clustering or k-mean. Let me know if you have any question or doubt. In the next lecture, I will give you a small project on this. Thank you.